3I Atlas is the third confirmed interstellar object to enter our solar system. It came silently from the darkness between the stars, an ancient traveler older than our sun. When telescopes first caught its faint shimmer on July 1, 2025, astronomers knew this wasn't an ordinary comet. Its hyperbolic path means it isn't bound to the sun. Hubble images show a teardrop-shaped dust coma around a solid icy nucleus as it races at well over 200,000 kilometers per hour, heading for a brief passage through the inner solar system before returning to interstellar space. It is safely distant from Earth. The scientific race is to measure, map, and decode it before it's gone. Today, we look at what it is, where it might have formed, and why its chemistry is unlike most comets we know. Days after discovery, Gemini and ESO's Very Large Telescope captured sequences confirming a compact coma and a developing tail. These early frames helped nail down the object's motion and brightness behavior and confirmed 3I Atlas is cometary, not an inert rock. ESO's time-lapse from the 3rd of July 2025 shows motion against the star field. The orbit of 3I Atlas doesn't loop around the Sun. It slices through and escapes. Its path is unmistakably hyperbolic, not a closed ellipse, meaning its eccentricity is above 1, and it's not bound by the Sun's gravity. It arrives on a steep retrograde trajectory, cutting across the plane of the planets rather than following them. Its closest approach to the Sun, perihelion, takes place in late October 2025, just inside Mars' orbit. Yet from our vantage point, its solar elongation is such that observation windows will be tightly constrained. In short, the shape of the path alone tells us this object came from beyond our solar system. Vera C. Rubin Observatory inadvertently caught 3I Atlas during commissioning. Analyses suggest a kilometer-scale nucleus, with some reports estimating a few kilometers across, potentially larger than previous interstellar visitors. This doesn't settle every debate, but it sets a scale for dust production and outgassing and hints that interstellar comets can be substantial bodies. Spectroscopy points to unusual chemistry. Observers reported CO₂-dominated outgassing with detectable H2O and CO. The CO₂-H2O ratio appears high relative to many solar system comets, implying formation in a cold, CO₂-preserving environment or prolonged processing in interstellar space. Spectrographs caught something strange, traces of nickel glimmering in the comet's light, yet iron was almost missing. In every ordinary comet, these two metals appear hand in hand, forged together in the same cosmic furnace. But 3I Atlas broke that rule. Scientists are now testing whether the nickel escaped as a volatile gas compound, or if the object's surface hides unfamiliar chemistry born in another star system. Whatever the reason, this metal imbalance adds one more line to the list of mysteries that set 3I Atlas apart from anything we've ever studied. As 3I Atlas began drifting closer to the Sun, its long frozen surface finally started to awaken. For millions of years, this object had wandered in the deep cold between the stars, a place where sunlight never reached, and even the hardest ices remained locked in eternal silence. But now, that silence was breaking. The rising heat ignited the process of sublimation. The frozen carbon dioxide, water, and exotic interstellar compounds began to vaporize directly into gas, throwing jets of material into the surrounding void. Scientists observing from Earth and space watched this transformation unfold in real time. Every flare, every burst of activity revealed how differently 3I Atlas behaved compared to the comets born in our own solar system. Its coma was dense with carbon dioxide, far more than water vapor, and that imbalance changed everything. It altered the pressure of escaping gases, shifted the shape of its tail, and even changed the way sunlight reflected from its surface. Some models suggest that this carbon dioxide-rich composition may have come from a world orbiting far from its original star solar soak, a frozen exoplanetary nursery where temperatures dropped so low that only CO2 ice could survive. As it passed near the Sun, those ancient ices spoke again, telling the story of a system light years away. And even though the object will soon vanish forever into interstellar darkness, the traces it left, spectra, images, and light curves, will help us understand how alien worlds may be born. As 3I Atlas crossed the inner system, multiple missions and observatories coordinated observations. Graphics from ESA NASA summarize which spacecraft had favorable vantage points. This multi-angle watch helps separate instrument artifacts from real comet behavior. Capturing an interstellar comet after discovery is extremely hard. Late detection, high speed, and wrong geometry. Even with a powerful launcher and gravity assists, mission design windows are fleeting. Future standby interceptors or rapid response missions could change the game. But 3I Atlas itself is a missed intercept opportunity. Astronomers followed the fading line of 3I Atlas across star charts, retracing its path through the neighborhood of nearby Sun. Each trace led to silence. No parent star, no home system, only the long arc of an ancient journey through the galaxy. Perhaps it was thrown free when its birth star collapsed, or scattered by a passing giant long before Earth existed. Now it drifts alone, its trajectory stretching beyond every known map, a messenger without a return address. Compared to solar system comets, 3I Atlas shows chemistry diversity and activity patterns that stretch our models. A CO₂-rich coma, debated metal signatures, and large size imply interstellar comets may be more varied than our samples suggest. With Rubin coming online and survey cadence improving, we expect more interstellar visitors, and we must be ready to measure early. As 3I Atlas fades into the dark, something about it still pulls us in. It came from nowhere, left us with questions, and vanished like a dream. Every image, every signal, it's like a whisper from another world. Maybe it's gone, or maybe it's just the first of many. Somewhere out there, another traveler could already be heading our way. We're watching, waiting, wondering what stories the next one will tell. The universe doesn't give easy answers, it gives mysteries. And that's what makes it beautiful. Stay curious, keep looking up. And subscribe to The Enigmatic for more 3I Atlas updates. Comment your thoughts below. What do you think it really is?